Hello, everyone. Welcome back to the Day Zero podcast, our first bounty episode after the summer break. I'm Spectre, with me is Z. Hopefully, everyone had a cool summer. There was actually a decent bit of cool write ups and news and whatnot that came out throughout the summer, some of which were literally like the week after we took the break. So we were having a bit of a chuckle about that in the Discord. And yeah, because of that, this week we're going to cover some stuff, a few of which that were bounty topics that happened throughout the summer. So not necessarily super recent within like the last couple weeks like we usually do. But yeah, we'll have some posts in here from like August and July and whatnot. Just stuff that we thought was cool and got some good attention on social media as well.
Yeah,
So
not recent, but worth talking about.
yeah, exactly. Um, a lot of them were binary, so tomorrow's episode will be fairly stacked. But yeah, today, of course, we have bounty topics, and we'll be. I guess I'll also mention pretty much everything with the podcast. We'll be saying the same as it was before, same times. We have gone back to retroactively number episodes. Some of you might notice on like our YouTube or whatever. Part of the reasoning for that, if anyone's curious, is we originally stopped doing the numbering episodes like a year or two ago because we thought it was kind of redundant, that it wasn't really adding much. But then we realized whenever we tried to refer back to episodes, it was a little bit awkward because we had to use dates. And don't dates don't really work that well because they're not searchable. So that's why we're going back to the numbered episodes. Figured I'd call it out in case anyone notices it, but not really a huge change there either.
Not searchable, and the other aspect is just we stream these, on Mondays, Tuesdays, but we release them on Tuesdays and Wednesdays. So we kind of have the desync between like what is our Tuesday episode? Is it the day we stream or the day we release it?
Yeah, that also made it weird with dates. So numbers just makes it so much easier. So that's why we're going back to that. All right, so we'll start off with a bit of a lighter story from Mod Zero that was posted in August around their vulnerability disclosure process with CrowdStrike and their Falcon Sensor product, um, which is a little bit interesting because, for one, CrowdStrike is a security IT company and because of that, you'd expect them to have like a reasonable and sane disclosure process. So it's a little bit jarring to see such a harsh criticism of it. Although whether that criticism is valid or not, I guess we'll get to. Um, and yeah, just the other aspect was that Mod Zero was challenging CrowdStrike with some harsh words there. Um, and while we have covered some of these types of situations before, it's been a little while, and we do kind of like looking at stuff like this and trying to see both sides of it. So I guess we'll start off with the advisory that Mod Zero published, which is they link off to in their blog post here. Um, which basically this was an uninstall protection bypass for Falcon Sensor, which is CrowdStrike's antivirus and endpoint detection and response service all bundled together. And because of that, it provides an uninstall protection to prevent some malicious piece of code or whatever from uninstalling Falcon Sensor without a one-time generated token. So that something malicious can't just uninstall and circumvent the endpoint protection. Mod Zero found a way around it though. Unfortunately, they don't really talk about how they did that. I actually had to dig through their proof of concept to see what they were doing. But basically, they were programmatically opening the uninstaller and then killing the third and fourth processes that would get launched. They don't really go into further detail on that at all. They mostly just focus on the drama part of that. But it seems whatever happens there, those processes that they kill are responsible for enforcing that token authentication. So by killing those processes, it breaks the token auth check, and they can just go on and uninstall without needing it. Um, if my reading of the proof of concept is correct, it seems there might be a bit of a race aspect to this too. It when you read their POC, you'll see that they take care to get real time priority, so that they can't be like preempted or anything like that. And they're also like careful to extremely quickly kill those processes as soon as they come up. I thought that was a little bit interesting, which is why I wish there was a bit more technical details here, if there is like a race aspect to it. But that's just pure speculation based on reading the POC code here. I don't know for sure.
Yeah, like
Um,
from the information given, like at first when you say okay, they're killing some background process that get launched, it sounds like it's just a fail open sort of situation where it doesn't exist. Well, then it just ends up ignoring some of the errors and kind of returns true sort of thing. But then when you see, as you're just mentioning, the um getting the priority or like the real time priority there. I don't know. There seems to be more depth to this that just isn't included. Although they do call this out in the advisory that like the vulnerability, or in the original post, not the advisory. The vulnerability was necessarily too interesting, but this whole disclosure process has been. So I don't know. Maybe we are just reading too much into it, and they just copy and pasted some code that just had that in it and like didn't worry about it. Um, I'm not sure there, but it feels like there is a little bit more depth than we're getting, and I really wish we would have gotten it.
Yeah. Instead, they focused a bit more on the drama side of things, which I guess we'll get to now. Um, And what Mod Zero focused on was the drama with the disclosure process. To sum it up, CrowdStrike refused to accept the report or communicate with Mod Zero without directing them through their HackerOne program, which Mod Zero didn't want to submit through because if they did, obviously they'd be under HackerOne's disclosure terms, which includes like not being able to disclose without vendor permission, or if you do, then you'll get banned off the platform. Um, there was a little bit more discussion. Seems that CrowdStrike tried to open a bit more of a dialogue, and those discussions didn't go anywhere. Um, then a later update of the sensor flagged what their exploit was doing as malicious behavior, and so Mod Zero kind of sees it as, I guess they got screwed a little bit. They see it as them trying to fix the issue while stating it doesn't exist, which they see as disrespectful. To be honest, I don't really understand the point that they have here, because nowhere above that statement did they mention CrowdStrike saying it wasn't an issue. From my read of it, it just seems they wanted to direct them through the HackerOne and didn't want to communicate with them outside of that, which I mean, I can kind of understand why they wouldn't want to be bound under HackerOne's conditions if they're more of like the open disclosure kind of route. Um, but that is the channel that CrowdStrike has chosen to establish, and I mean, it's not like they should want to have to communicate off of HackerOne either. I mean, it would be kind of unreasonable if every researcher that wanted to submit things was able to dictate, what platform was being used or whatever, right?
So I
Um,
kind of get where Mod Zero seems to come from, in terms of feeling like they might be getting screwed by them. In the sense of at least HackerOne, generally speaking, you've got bounties. I'm not sure what the policy is for CrowdStrike specifically on bounties, but you've got that idea. And when you are going through a separate mechanism, like not using HackerOne, they don't necessarily need to offer up those same bounties anymore because you're not agreeing to the same terms. So I can kind of see there being something like that where they didn't receive any sort of confirmation that this was agreed to. So seeing as or that it was an actual vulnerability. So I can kind of see them treating it as the fact that um they don't have a positive acknowledgement as being the issue rather than the fact they haven't declined to do it. If that makes sense.
Yeah, that's kind of how I read it too. It's just like, they wanted to communicate on HackerOne and Mod Zero didn't want to use HackerOne, and that's kind of where the problems came to be. Um yeah, there was I did see some controversy on if this was even really like a vulnerability, because you do need a high level of access to be able to pull this off. You need to have admin privileges to be able to kill the process. It's not like you can be an untrusted user and just run this exploit and uninstall um, Falcon Sensor. So it is a fairly low impact vulnerability. Some people were challenging if it's even a vulnerability at all. Um, I was kind of on the fence with that as well. I talked with Z a little bit about this actually the other day, and I think it is fair to call it a vulnerability, albeit a low impact one. And to be fair to Mod Zero, like they do state up front what the limitations are of the vulnerability and how impactful it is. But yeah, I do think it was a little unfair for people to say that this isn't a vulnerability. Like the uninstall protection is there for a reason. They do try to have it so that malware can't uninstall it. Even if that malware has to be admin, it still is bypassing something that's intended to be there. So
Yeah, and where the difference kind of appears to me on this one is that if this were the case where just being admin meant like you can invoke the uninstaller and like there was no sort of protection there, just if you're admin, you can uninstall, then I wouldn't necessarily see this as a vulnerability. That's just the functionality. They have a feature that stops users from uninstalling, but not admins. in this case, though, they are needing to take these extra steps to kill off those background process, in order for the admin to be able to do the uninstall. So yes, it does require admin, but the admin even shouldn't be able to. Therefore, they are kind of passing a security boundary. But this does also feel like it could be seen as a kind of weaker security boundary, kind of like UAC on Microsoft. I think we've used as an example of this before, where with UAC, it's like Microsoft has that. It is kind of a security mechanism that exists, but it's not a security boundary. So, like, bypassing it, they don't care about. You could kind of see this in a similar sense where I would argue in both cases, you're still getting around something. So, it's still a security issue. How severe it is kind of up to the vendor. But yeah, in this case, like, there is something there that's being bypassed. I think it would be easier with more information about it, because I think a lot of people might just walk away thinking admins in general can uninstall and somehow that's a vulnerability, and that isn't the case here. It is a little bit more substantial than that.
Yeah, and to be fair to those people, like I said, I had to dig through the POC to see what they were doing. They don't really talk about it at all, so um, I guess I can forgive people a little bit for thinking like it's just, oh, admin can uninstall. That's, whatever. Water's wet. More news at 11. But yeah, there is a little bit more nuance to it than that.
Yeah, they're missing, like, the vulnerability report itself feels like it's missing a lot of it. Well, it is missing a lot of information. It's focused on just the drama there. On the
Yeah.
drama front, I kind of just want to comment there because we're actually going to have another topic a bit later that deals with another issue where the official policy, using HackerOne or anything else, but some people don't want to go through that sort of disclosure, and that's where I understand companies wanting to force you to use HackerOne, but HackerOne, like, you do have to agree to HackerOne's terms. You may not agree to that as a researcher. And I do think it's important that companies have a means for vulnerabilities to be disclosed, even without going through a third party program. I think they should have a third party program. Well, I mean, they can run it in house too, but, like, I think third parties a fine strategy. But having some sort of mechanism, making it easier for people, just making it easy just to disclose, however people want to disclose.
Even if it's just a security email,
Yeah,
that'd probably be good enough.
I mean, an email in security.txt.
On the other hand, though, like, there is a lot to be said for like what HackerOne provides for companies, because companies that do run their own like independent vulnerability disclosure program, they then also have to take on that workload of triaging and dealing with like a bunch of bad reports that aren't even real vulns and having to sort through that. Whereas HackerOne, you don't have to deal with that to the same degree. You can even have like HackerOne staff like triage and stuff like that for you. So I can see why companies want to keep it to HackerOne and don't have any other avenues. But like you're saying, it would be nice for researchers to be able to not have to deal with HackerOne's terms if they don't want to. But it's kind of a situation where both sides have like different interests, and there's a bit of a conflict there, I guess.
I mean, the main thing is really just down to disclosure. Um, as much as I'm, okay with companies not wanting to disclose vulnerabilities through bug bounties, if people are willing to not take the bounty and in exchange get to talk about their vulnerabilities, like, I would rather not even need to be a choice, so you can both get a bounty and talk about the vulnerability. But I get kind of the secrecy on one side. But if security is the goal, making it easy to report a vulnerability should also be part of that goal, regardless of whether or not they're going to also talk about it or disclose it. Because forcing through HackerOne is also kind of forcing them into silence in some cases, into you can't talk about our vulnerability without our permission to disclose.
Even if you don't get paid for it,
Yeah,
and they don't fix it.
Yeah, that's where you keep using HackerOne, bug crowd, integrity, same deal. It's just kind of in general. But if you're caring about security, it should just be about, can you get the vulnerability report? That's kind of the most important thing. Not so much whether or not people agree to your terms, because researchers often disagree on the terms. There's debate over how to handle disclosures within the community all the time.
Yeah. All right, so we'll get into our next topic here, which is kind of a funny HackerOne report that was submitted to GitLab. in which the impact was the ability to read HackerOne report and attachments without authorization. So a very meta issue, though also a fairly simple one. It seems that GitLab had internal tracking of HackerOne reports and would like back up attachments related to them in an internal domain of theirs, which was this h1.sec.gitlab.net domain. And the researcher had found one of these links through one avenue or another. And when they just went to this /a path that they mention, they could view all the attachment keys and then construct the URLs manually to download the attachments. And it seems there was no like authentication built on these links. It was just like, it's a secret link and the keys are there, but if you have the key, then you have access to it. So yeah, obviously fairly simple issue, but fairly impactful if you were looking for free 0 days before they get fixed. So obviously this was rated a critical severity CVE. It was given a $12,000 bounty. But yeah, I mainly wanted to talk about this one, not so much because the issue was interesting, because it wasn't, but just kind of funny on the impact side of things, and the fact that they were backing up HackerOne reports in this way, and you were able to just like get access to them through this GitLab internal domain. So yeah, a bit of a weird situation, and not really one you'd expect to see out of like someone like GitLab, but it was there. So
Yeah, I mean, it kind of feels like the sort of thing that's developed as this really quick. Well, the part that doesn't entirely make sense to me is why the endpoint existed to list all of the keys. Because it makes sense, like that they might back it up and that they might store these attachments elsewhere. That's fair. It's then exposing all of the attachment keys publicly that just feels like I'm not sure why they would do that. Although I also didn't try looking into this report too deeply.
yeah, maybe just one of those things that was there for development. They wanted to have like the ability to dump everything that was there, and then it just was left open or something. I don't know. Yeah, I thought that was weird too, but
Yeah, I mean,
yeah,
it
I
does
mean,
seem intentional just because it is A for attachments. It just feels weird that they would have it. Or at least I'm
yeah,
assuming A for attachments. Maybe it was like a temporary developer thing, like, oh, I need a random path because I need to get this key or whatever. And oh, let's just use A, and that's what happened. I could imagine that happening too, and it kind of being unintentional in that sense. But right now, I'm at least seeing a connection between A and attachments.
yeah. The other funny thing is, it seems it took a little bit for them to fix this issue, even though it seemed like a really simple issue, because it was reported in September of 2 years ago. But then I don't think it was acknowledged until like November. That's when they awarded the bounty, so they might have fixed it before then, to be fair. But yeah, the timeline was a little interesting, because they requested to disclose the GitLab staff requested to disclose a report 2 years ago as well, and then it only finally got disclosed like 2 months ago. So it's a bit of an older issue too, but yeah, kind of funny what the details were there.
Actually, the timeline. Oh no. Okay. So I was going to call it the timeline going from September to November to October as being really weird, but I think that's just because this one was updated again in November. It probably had other content and was originally posted in September, like between those two dates. So
Yeah. All right, so next we have a post by Microsoft Defender's research team on a TikTok vulnerability in the Android app. For those that might be thinking, this is a little weird. Why are we getting a Microsoft blog post on the TikTok Android app? I know Windows 11 sucks, and therefore almost nobody willingly uses it, but Windows 11 does add support for running Android applications natively, and TikTok is probably one of the most popular applications out there, if not the most popular. So it kind of makes sense with that context that the 365 Defender research team would be looking at it. Anyway, the vulnerability here that they detail is kind of two vulnerabilities, but only one that TikTok actually considers a vulnerability. And it affects both the Asian and international flavors of the application. Before going into details on the vuln, Microsoft first details what a web view is, which is a component provided by Android to display web pages. Critically, though, it also supports this bridge functionality to allow it to invoke Java methods of a class in an application. And so any untrusted content in the web view is pretty dangerous because it can allow access to those methods which can allow like leak of, or corruption of data, potentially arbitrary code execution in some cases. So yeah, it's fairly important to keep untrusted content out of the web view, basically.
There's a lot that can happen, but at the same time, you need those targets and those interfaces to actually exist that you're going to try and open with it. Like the web view having untrusted content isn't necessarily the issue. It's the web view untrusted content plus the handlers. Like
Yeah.
you need everything.
So the vulnerability here primarily is when deep links come into play, which for those not familiar, we've talked about them a few times. They're basically like powerful hyperlinks that can be routed to applications which have handlers set up for them. Now, because they're such a powerful feature, deep links do have to have intent filters set up in the manifest for the application, which specifies which URLs are acceptable for deep links and such. Often, apps will use deep links for internal actions like redirects or sharing or whatever it needs to do. Now, this is where the two issues sort of come into play. One of which is this redirect deep link. They don't go into too many details on it, but they basically just state that the redirect deep link, it takes like this query parameter, and you can use it to call into non-exported activities. Um, TikTok stated that they're fine with this. They don't really consider this a problem, but it does expand the attack surface and allow hitting the more critical issue, which was an internal scheme that would take a URL and load it into the web view. Now we were just talking about how you don't really want untrusted content ending up in there if you're using that bridge functionality and you have those handlers exposed. TikTok does have filters in place to try to prevent an untrusted host from being loaded in there, but it seems that protection was a little flimsy. Microsoft stated it could be bypassed by adding 2 additional parameters to the deep link. They don't really go into further detail there. A lot of the stuff is redacted. I guess TikTok didn't really want um, like deep internal details of the vulnerability being published.
I'm a little curious about why they do the redaction.
Yeah, I
Like,
was too.
it makes sense, when a company publishes about their own vulnerabilities, okay, they might redact some information. In this case, it's like Microsoft and TikTok are not, as far as I'm aware, associated. I don't know, maybe Tencent owns Microsoft now or something. But
It's hard to keep track with all the company ownership nowadays.
yeah, I mean, I don't get why they're doing the redaction. It does feel a little bit weird, and it does prevent us from really kind of understanding the vulnerability. It's just you can bypass this with extra query parameters. That's not very useful.
Yeah,
Um,
and it's also not something you typically see in like an MSRC post. Typically, the Microsoft research posts go technically deep, and you get a lot out of them. Unfortunately, in this one, it's a high impact vulnerability, and there was some cool details there, so I still wanted to talk about it. But yeah, a lot of the deep technical details are kind of hidden away. They're not published here, so
out of
um,
chat, do have a hex name that I unfortunately can't read. 0x something, but trivial to find those schemes reversing the app. Yes, but with this issue, part of it is that you're able to redirect into the non-exposed schemes. So while a lot of schemes might be available just through reverse engineering, you won't be able unless they expose. Um, Basically, you're just able to using this. It kind of becomes a hop towards another issue. You'd use this in like a chain of you redirect to this accessible one, and then you're able to get access into all of their internal things that aren't intended to be exposed.
yeah. Which is why I would consider that redirect endpoint an issue, even though TikTok evidently doesn't consider that a problem.
Which
Microsoft,
there is a fair argument to be made that the redirect on its own, it's similar to like an open redirect vulnerability. It's not usually exploitable without some other issue existing. Without something else being used, it's going to be useful as part of a chain to escalate. But on its own, like if all of the interfaces don't do anything vulnerable, if none of them are doing anything of interest, um, or if all of them if you can load an admin interface, but since your account isn't an admin, like when it hits the server, nothing really happens. You just get to see the UI. That's not very useful, and it's kind of It's one of those things that because it's a defense in depth issue and not exploitable alone, a lot of companies tend to overlook them or just ignore them until they become an issue. So I guess that could even be why, actually, now that I think about why Microsoft didn't want to, or why they redacted this, because it's still in the TikTok app. And
Yeah.
thus just not wanting to add fuel to the fire.
Yeah, that's true. That's a fair point.
I
Um,
was thinking, okay, they probably still patch everything, but yeah, if they didn't, fair point on redacting it.
yeah, the thing with the redirect kind of falls into that category of some bugs you've talked about before, where it's like on its own you wouldn't submit it through like a bug bounty or whatever, but it's something you would note in a like audit. Um, as like a defense in depth type issue, but on its own, it's not really exploitable in a useful way to an attacker. But yeah, in this case, it did lead to being able to do something impactful, which Microsoft then does go on to detail towards the end of their post. They talk about some of the things that you could do with it, namely like session hijacking by sending requests and logging the cookie and request headers, or retrieving account data like private videos and settings by sending requests and getting a response back through a JavaScript callback. But yeah, again, they don't really go too much into that because of the redaction. So yeah, Microsoft disclosed that to TikTok in February this year, and it got fixed about a month or so later. But yeah, like I said, unfortunately, we don't have all of the details there. I think it could have been a cool vulnerability to see how they got the untrusted host loaded into the web view, but yeah, we just don't have that. So yeah, that's pretty much everything for the Microsoft topic for the TikTok phone. And with that, we'll move into our next post, which is by Synactive on a bug related to address forwarding in Apache's mod proxy reverse proxy module, and how it deals with the various forwarding headers. So, like X forwarded for, proto, post, etc. Something we talked about before, which is how stupid it can be with how forwarding IPs and keeping track through the chain. And here's just kind of another case of that happening. Um, the author states that mod proxy tries to follow the like written in standards as well as commonly accepted practices, but the vulnerability comes into play with X forwarded headers when they're tied in with hop by hop headers, which the proxy also supports. Hop by hopper is kind of like a weird mechanism that is not very fun to deal with, generally speaking. And yeah, obviously that's where the vulnerability comes into play here. Um,
The idea of hop by hop is really just headers that are relevant or added by like proxies in the way. So your X forwarded for is a hop by hop header because generally speaking, like your browser isn't going to send a hop by hop, but it will be added in during like the hopping between different servers.
Yeah. One thing I'll note at a chat. Yeah, sorry, the links aren't sending through to the chat like they have in the past. We'll have that fixed for next week and possibly if we can tomorrow.
Yeah, I broke
I
stuff this summer.
yeah, we were tinkering today. We had a good pre-stream, so yeah. Sorry about that though. If you do want the link though, I'll try to put them into chat as we go through. Um, yeah. So yeah, we were at the forwarding headers with the hop by hop. So what Synactive ended up noticing when they were playing with hop by hop headers, um, if the forwarding headers are sent in a hop by hop list, they don't get passed to the upstream, which they thought was really strange. And when they root caused it, they found it to be a logic bug in the AP proxy create header brgd function. I don't really know what all of that stands for. Now they do have like a code snippet of this function. Unfortunately, it doesn't really have the code that's responsible for the bug, as I can see it. Um, because under the code snippet, you can see this little section where they say what is important is that while the X forwarded addition code is called at line 4050 or so, the AP proxy clear connection function is called after that. So it's a really strange vuln, and I'll actually pull up the code on a GitHub repo that I found that shows the vulnerability a bit better. But they basically add the forwarding headers, and then they immediately clear the hop by hop options. So it's like they add them and then they immediately remove them. It's a bit of a weird bit of code, but yeah, that's what ended up happening there. I guess it's just a case of hop by hop header or forwarding headers not being passed through hop by hop very often. Maybe it's just an edge case that they didn't really consider or test for. So it just kind of slipped through under the radar, I guess. Synactive then goes on to detail some of the scenarios this could be exploited, such as Express.js and its trust proxy setting, which relies on the X-forwarded headers, and if none are present, it preserves the request values, which could be dangerous. Tomcat valves might rely on it. Basically, anywhere that the X-forwarded headers might be relied upon in some kind of middleware or whatever could be vulnerable to exploitation, but it's on a case-by-case basis of how this could be abused, basically.
Honestly, there are so many issues when it comes to X-forwarded 4. I mean, we covered a while
it's a
back.
Poisoned cup. Yeah, it's really hard to deal with.
Yeah, like, because we covered the one topic before break there where it was just like, here are all these issues with X-forwarded 4. Just hard to get right, kind of the edge cases, things I had no idea about, like, having basically the implicit treatment of translating multiple X-forwarded 4 headers into a list versus just providing them as a list. Anyway, that's unrelated to this vulnerability, so I won't go into it, but it's a lot more complex than you might think. So seeing some sort of little logic error here, like, it's weird, but it's not too surprising that, probably different developers just had some different assumptions and kind of led to that.
Yeah, and part of it is just the specifications are not really that good. They're pretty vague when it comes to certain areas. So when it comes to implementation, there's stuff that's left up to interpretation. It's like, oh, okay, what do we do in this case? All right, we'll do this. And there might be like a commonly accepted practice that a lot of things do, but because it's not in the specification, it doesn't have to be done that way. All it takes is one thing in the chain to do something a little differently, and then you have a problem. So yeah, like you said, it's one of those things that should be stupidly simple, and it's stupidly hard with X-forwarded headers. So, yeah, just another example of that, really. So, getting into some request smuggling, we have a smuggling or desync type vulnerability in Golang's net URL package and how it parses URLs, particularly when it came to semicolons. This is coming out of Oxeye. Before we get into the vulnerability, oh, sorry. Were you going to say something there? I'll let you go ahead.
I wanted to call something out here before we really jump into this post by the fact that they go through and they have this kind of pretty looking picture here to talk about URL parsing. So, like, here's the scheme and the authority and all of that. The annoying thing is this is taken from the RFC. The RFC, this is a very nice looking thing and everything lines up, but they took the screenshot and, like, here's your authority. It excludes the E and X from the URL and, ends in the path. Like, it doesn't line up. Why did they even take the picture? Why make it look nice if you can't even keep the important aspect of the data? Completely unrelated to the vulnerability. Well, I mean, it's parsing is related to the vulnerability, but doesn't really have any impact on the write-up, which is solid. It's a good write-up. This picture just, I don't know, it rubbed me the wrong way to see it not lining up.
It's funny because I saw that picture, obviously, like it's at the top, and I looked at it, but I didn't really like notice that, or I don't know, I just kind of glanced over it. I guess in my head I aligned them and it looked okay, but yeah, that is very off.
Yeah, I guess maybe if they use
weird.
some sort of app that creates the screenshots for them, then I guess the case would just be, monospace versus not monospace fonts.
Yeah, it's probably something dumb like that happened. But like you said, considering they're trying to call it the different fragments, this kind of goes against what the entire intent was of the image.
Yeah, it just looked weird when I saw it. Yeah. Anyway, let's jump into the vuln.
Yes. Well, before we get into the vulnerability, I do want to go over a bit of backstory here. And you could kind of consider this an older vulnerability in and of itself. Golang before 1.17 would actually parse semicolons as valid separators within a URL query, similar to an ampersand symbol. As per the RFC for the URI generic syntax, the semicolon is listed as a valid separator for the path, but not for the query. And similarly, the WhatWG URL spec lists ampersand as the only valid separator. And And because of that, other languages and their standard libraries like Node.js will not recognize a semicolon as a valid separator in the query. So because of that, in Golang 1.17, they made it so parse query would return an error if a query contained a semicolon. The fairly big issue here, though, and where the vulnerability is that they're talking about, is the URL package's query routine, which calls parse query, would explicitly ignore the return value of parse query. So, you would send a query, it would go on and do that error. It would see that, okay, there's a semicolon here, this is bad, reject it, return an error. Then query just kind of silently fails and moves on. Which leads to this situation where something running an older version of Golang, like if you have an older version running on the back end, it would parse a semicolon as a parameter separator, and then the newer version on the front end would just silently ignore it, which is kind of the perfect soup for a smuggling attack. On top of that, Golang offers built-in support for HTTP proxy using the HTTP util module. And what they hammer on there is the new single host reverse proxy method. And that would just take a raw query string and send it as is without doing any parsing on it. So Oxeye was able to find multiple open source projects that were vulnerable to desync attack because of this version difference and the different behavior there, including a project called Harbor, which was a registry for artifacts with access control and such, where their auth could be bypassed by smuggling parameters that were blocked by the front end. Unfortunately, this one's a little bit weird in how their POC works. They don't really go through like the exact way they set up the URL there, but
Yeah, so
yeah,
I dug into this a little bit because it was somewhat confusing. So the idea here, on the core vulnerability is just old versions um of Go will parse if you use the semicolon, and newer versions uh they won't see it as a separate thing. So they have this vulnerability that they specifically call out in this blobs upload path. It also has like the repository name, project name, blobs upload, and then you can basically just mount a file system from some uh other Docker container, Docker setup. Basically, just mounting an external thing that's not actually part of your project. You're say, okay, well, from this other project, do this. Um, what seemed weird to me is they have this vulnerability image of their request, and you'll see what they do is they send from with the semicolon and then the ampersand and then mount. Um, and apparently that will get parsed somehow. That's vulnerable. I don't know if like this picture, like I don't see how this picture can be wrong. It just doesn't make sense to me because even with this setup, I believe it will still parse a value for from. And develop well, actually I guess now that I'm thinking about it, I did dig into some of the code here. I'll pull up. Okay, sorry, it's the links are connecting now in my head a little bit. So with this post initiate blah blah blah, I had to dig through their code to actually find where the route was getting handled. It effectively looks if mount is empty when it parses it, it's going to return nil. In one of the other areas, it comments that it's going to skip some of the security checks. There's two handlers kind of in a chain for this post. I'll have the other one in the show notes. But either way, when mount is empty, it decides, hey, this isn't an important, or this doesn't need the extra security check. So that's how it's able to bypass it because um, I seem to have actually lost there it is, our topic link. When this happens, it gets the error when it sees the ampersand, so it's not going to add the mount flag, thinking mount is empty, but it's still going to pass it on to Docker, which is the back end side of this, basically creating the case where front end doesn't see mount, back end sees mount, and does something sensitive. So interesting bug. I'm sorry I kind of rambled a little bit on explaining that aspect. I had to dig into this a bit to get exactly how that would create an issue because I didn't see it initially.
yeah. So you're basically smuggling the mount parameter in.
Yes.
It's invisible to the front end, which makes sense. So, um,
Yeah, so
Yeah,
I sorry, go ahead.
yeah, I was just gonna say it creates kind of this subtle logic issue, where yeah, I mean that's what desync attacks do, I guess. But yeah, sorry, go ahead.
Yeah, well, I mean, it is that kind of smuggling idea of you're able to get an argument that one of them won't see into the other. Um,
Yeah, and
Interesting
obviously because
area.
the auth is on the front end, it can't do anything about it. Once it reaches the back end, it's there. It's gonna go through. Um, yeah, any of the authentication that would be able to filter this out is
Yeah,
bypassed.
well, that's kind of the thing. This isn't like you can sometimes think about these in the sense of like a front end, like reverse proxy to your application. This is more of a case of the application forwarding a request. Um, like Docker isn't really Harbor service. That's something else. Somebody else kind of makes Docker. So it is separate from. So it does create an interesting area. Just for looking for attacks, really, where it's communicating with some other API. In this case, the Docker API that ends up being vulnerable, and you're able to smuggle into. I don't know, it's an interesting vuln. As time goes
Yeah,
forward, you're
it's
probably going
worth
to.
noting there were some other cases that they detail here. There was proxies like Trifec and the Skipper router and reverse proxy. They have some rule filters which could be bypassed with the same attack. Um, they don't really go into like as deep of detail as they do with the Harbor, but yeah, it's worth calling out that it's
No,
there.
so part of that's because the Harbor one, they found a specific the Bitnami deployment that used this sort of vulnerable thing because this does depend on having different versions of Go compile your different services. Docker being compiled by one service and Harbor by or with one version, Harbor by another. So they had a very concrete example. Whereas with Skipper and Traffic, these are just in general, these Golang proxies could be vulnerable to this.
Yeah, but
But
it's
they,
kind of on a case by case basis.
yeah, whereas the other one has a concrete case. I don't know. It's something to keep an eye out for. As time goes on, I'm going to expect, you're going to see just newer Go coming through. Um, I don't know. It's an interesting vulnerability though, to say the least about it.
Yeah,
I feel like I mean this kind of just comes down like these things in general have been really interesting, and this isn't the first time we've seen anything with parameter smuggling, but it is an interesting case because it is kind of built into the language in this case.
yeah, I think this might be the first time we've seen one that's sourced from the standard library, or like an issue that was in the standard library for the language. Maybe there was another one and I just can't think of it, but yeah, it's most smuggling you see is down to like implementation errors on third parties, not really in the standard library. So in the remediation section near the end, they put out a semgrep rule they released to check if your code is vulnerable to this. And they say you may want to serialize your raw queries against semicolons. Really, though, I think the better solution is just to make sure your backend and front end services are synced on the same version of software, preferably the newer one. Though,
That's hard to do
unfortunately,
because you're talking about compiled binaries like Docker. Are you really going to? I mean, some people probably do compile their own versions of Docker, but you're probably just going to use a pre-built.
that's true. Yeah. And I was just about to get into that because especially with Golang, um, there were some like breaking changes in the language with when it comes to like modules and whatnot. So it could require some significant reworks of the code bases to make it compatible to upgrade your version. Or you'd have to use hacks like the Go 111 modules thing. But yeah, I mean it's kind of an interesting desync scenario, and it's probably one that's somewhat common or more common than you might think. Just because like I doubt most people are even aware of this change in Go 1.17 or the implications that it might have. It's one of those like subtle version things where it's like if you know about it, you know, and if you don't, you're probably not going to find out unless you get hit by it. So yeah, that's what makes it a pretty interesting attack scenario and one that could be seen in like live projects today and going into the future. So um, yeah, cool post by Oxide. I really enjoyed this one, and I mean, we always kind of say that though, like we just really like the desync and smuggling based attacks,
They're
which is why
very
we have two of them.
fun. Yeah, they're very fun vulnerabilities. And I guess I will maybe backstep one of my comments there where I mentioned about, as time goes on, you're going to see newer and newer versions of Go. That is true. But at the same time, I believe this was changed in Go in 2017. At least they linked to one of the issues that talks about this issue and like the change in 17. I'm not sure exactly when it landed, so do you know when 1.17 landed?
I don't remember the exact date. Let me just do a quick look up. 1.17 was
Okay, it was actually
2021
just
August.
2021. Okay, for some reason I
Yeah.
thought it landed in 2018. Um, Although no, if it just landed, then that's much more recent, and I can't really say people are sticking on older versions that long. So never mind,
Yeah,
recent change.
I remember because I looked at the Golang issue that you were talking about. It was submitted in 2018 on the GitHub, and I think there was some back and forth on like whether or not this was even a bug. Like there was some argument that semicolon was supposed to be a valid separator, and then they were digging into the specs and such. So there was some disagreement on that original issue. Um, that did eventually get shipped in 1.17, and I guess that's part of why there was such a gap between when it was reported and when it was actually tabled um, for a patch. So yeah, that's another interesting aspect of it.
Yeah, I think I missed that aspect. I definitely saw that it was in 2018 where they were discussing it, so I just assumed it was around then, but I guess I was mistaken on that.
Yeah. So, like I said, we really like the desync type attacks, and we do have two of them in this episode because Portswigger put out a post in August as well about desync attacks. This one got a good bit of attention. It's called Browser Powered Desync Attacks. This was also presented as a talk at Black Hat as well and DEF CON. Sadly, Z and I didn't go this year. And last I looked for the talks, they weren't up on YouTube yet. We were kind of hoping that the live streams and the immediate VODs that we had last year that would continue going forward with DEF CON, but it seems like they've gone back to how it was pre-pandemic, so we'll probably have to wait a few months for the talks, which kind of sucks, but that's the way they've decided to go with it. But yeah, there were some presentations for this, and this is kind of like the paper that's laying it out. So it's a pretty long post by James Kettle, but there's a lot of cool stuff here. Z, I'll let you get into this one.
Yeah, and this was a very long post. I do look forward to actually seeing the presentation on it. Although I will also call out that there is a lot of information just on some practical advice towards testing and detecting more traditional request smuggling. But the new things here are they're calling these browser powered desyncs or client side desync. And the key thing there being uh normally when we're talking about the request smuggling, what's going on is you have like a front end and a back end server, so like a reverse proxying than your actual application server. And the reverse proxying application disagree on how to parse a request, and you end up with request smuggling where you can get one in that one of them wasn't expecting or the front end didn't see, so it didn't like block you from accessing an admin page or whatever. There are different ways you can go about actually attacking that. Um, the client side desync, what's interesting here is that it happens between the client or the browser and the server, as opposed to the traditional ones being. You actually also introduces the term server side desync to refer to those where it's the servers disagreeing. The side client side, it's the browser disagreeing. And the case that he calls out, I wouldn't be surprised if somebody figured out some other new request smuggling that can be done client side also. But he calls out that this specifically when some servers will ignore content length values. So as an example, you might just have like IoT servers might just basically only expect GET requests, so they just don't even parse for a body. They just assume everything coming in is GET and there's no body, and it doesn't even care if you provide a content length and send a post. It's going to, treat it badly. Other things, though, they call out a little bit more common, or at least for websites you might be browsing on a day-to-day basis, um, would end up being either servers doing that same thing, just not expecting on some endpoints. Odds are most web servers are at least going to expect posts somewhere, be able to handle that. You'd hope, but kind of having that situation there or on just your average website, not just IoT. I can just really imagine on IoT. I don't think he actually. I can't remember if he calls out the IoT aspect. Oh yeah, I guess he does mention.
I believe he does. Yeah.
Yeah, I dread to think how many IoT devices are vulnerable. It's not really a focus. His main thing is just you basically have the scenario where content length is being ignored for some reason. Another case of that is if you do have a reverse proxy that maybe does a redirect. So it sees like, oh, you're trying to access this page and just issues the redirect without processing the rest of it. It just sees you're going somewhere else or whatever. Has like an early return or a server error can lead to the content length being ignored. Like malformed requests might do that, although an interesting aspect of this is not using malformed requests, so I won't dive into that case. But yeah, the general idea just comes down to for some reason, some server's going to have a content length or not going to handle your content length appropriately. And so what ends up happening is you send in a post request. I actually think this is an example on screen. No, it's not. Next one is. You send in like a post request. And it's just going to treat that as, hey, I don't care that this is post. I don't care about any request bodies, even though you've got a content length. I don't care. And it's just going to issue its 301 move permanently to, in this case, it's just redirecting people. So then your actual body gets put in as the start of the next request. So then the next time you send a request over there, your browser is usually going to, connection keep alive. It's going to keep that connection alive. And it's going to reuse that same socket. So now when it issues the second request, your body of your first request is going to be treated as a prefix to the second request, meaning you can control maybe the location of it. You control like that get line, the verb line. You can control any cookies that are passed into it, whatever. You basically can craft a prefix onto any further requests. And because this is all happening just in the client, so first, I guess I will mention, so you can control the headers. You can smuggle in like the prefix part of the headers there. And this is all happening inside the client. So you can do this with like a fetch in JavaScript. So you kind of have the same sort of CSRF scenario where somebody visits an attacker website and then makes these requests. You can now do this sort of request smuggling if the target is vulnerable to it. You can now make requests, but you can control the headers in your victim's requests, which is a really interesting attack surface.
Now, I do want to call out something else that's kind of critical to these vulnerabilities is the fact that like in a lot of these cases, the HTTP servers will assume that the multiple requests over a single connection are like connected and share a state, which they call out as like problematic. Like you should be treating different HTTP requests as separate entities. You shouldn't be having this situation where you can parse like multiple headers from the same connection, have them treated as like having something in common. That's one thing they like point out and is kind of core to these. So I just wanted to shout that out before getting into like the details.
He kind of calls that out. So early on in this post, you get a bit of a review, you get a bit of a talk actually about connection locked request smuggling, which is where you can't do like cross-user stuff because every time, I'm not going to dive into that actually right now, but he goes into other sorts of attacks. I am kind of glossing over here. And I feel like that aspect, it kind of falls into one of these details that he includes early on, and it's really important to understanding why this ends up happening. I'm just kind of focusing on here's what ends up happening. But yeah, there's a lot of background. This is a really long post. There's a lot of really good information if you want to go and test for this issue, either for the new desyncs or just for the desyncs in general and request smuggling. Tons of advice in here. And as Spec was just talking about, it does talk about these connection state attacks where occasionally you can not necessarily kind of request smuggling. But the idea being where the server may just look at the first request that comes in and be like, oh, this is going to whatever host, and then just creates a connection to that backend host and starts forwarding your requests over to it, acting, like the normal reverse proxy would act. But then if you send another header and give it or you send another request in there and just give it a different host, because it's the same connection, it only validated or did checking on the one. It just kind of lets it through. Also a really cool attack, but not exactly the focus of the post, I guess. But kind of helps you understand the context of it.
Yeah.
So yeah, jumping back into this though, the interesting with, or part of the interesting with these client-side desyncs is that these can happen just your JavaScript fetch, and you're getting control of headers that are made, or at least what's interpreted as headers in the browser. So you kind of have access to doing things like crafting a content type application JSON header. So a common defense against C-serve attacks would just be checking that content type header, because cross-site or cross-origin, cross-site requests can't set that header, at least not without having a CORS policy that allows it. So you're able to kind of craft that. You're also able to access like the host header, have a malicious host header. Basically, control of headers. I don't know a good way to succinctly sum this up, but you're getting access to a big attack surface of vulnerabilities that normally you wouldn't care a ton about. Like their issues. For example, cross-site scripting through a host header. It exists, it's out there, but you can't really exploit that against somebody. If you have this sort of client-side desync, now you can. Now you can actually craft a request with a modified host and have it happen in the browser when an attacker just visits your website, or sorry, when a victim visits the attacker's website. So it opens up like a lot of escalation aspect to have some issues that can be escalated to something more serious. Granted, I'm going to say the request smuggling itself is, well, I was going to say it's a more serious vulnerability, but that's going to be debatable depending on what you can actually make a request with. On that note, this post has some case studies that I won't dive into. Goes into a lot of the exploitation strategy also for different attacks, different ways you can take advantage of this. Believe the one he calls out, well, he calls them out as just categories. Chain and pivot is kind of what I'm talking about, where you can do like web cache poisoning. He actually walks through a case where he managed to corrupt the host header, so the return JavaScript, it'll fetch JavaScript from an attacker's domain, but it'll load it thinking that it's a local, like the same domain as the actual request was on, because he smuggled in that early host header. He goes into different attacks with that. Interesting stuff, an interesting vulnerability, an interesting idea. I'll be interested to see more reports about it. Obviously, this is really just coming out now, so we haven't seen a lot of it. This is a research post. But yeah, really cool, and I think it opens up some interesting attack vectors. And the last one there, I guess I'll also call out, is in addition to the browser powered desync, or this client-side one, there is also a pause-based desync. Simple idea there being, if a request like times out, or if you're basically able to start a request, pause it, have it time out, and then keep sending it, you can sometimes have a desync where all that stuff you sent after the timeout is treated as a new request, went to the browser, to the source, whatever's sending it, thinks it's just sending one request. Was named to actually reproduce this in a browser. Talks a little bit about streaming fetch as a way of maybe being able to send some of the headers and have a pause before it sends more, but that's like not implemented anywhere, wasn't successful. So the only real attack he had with this one was if you're in like a man in the middle situation where you already have a good deal of control.
I will
But
say that pause based desync. What was kind of funny about that one was he actually discovered it by accident.
Yeah.
because he had like an internal tool he was working on that was supposed to have a 2-second timeout, but it actually had 10 seconds. And then he was testing with a Varnish config with a 5-second timeout, and it turned out that in this specific case with Varnish, Varnish Cache supports something called synth rules, which you could use to issue responses without forwarding the request on. And if a partial request was received that matched a synth rule, there was that timeout, but it'll leave the connection open for reuse. So that's kind of where that issue cropped up, where they were able to get another request that was sent after the timeout parsed as like a fresh request. So that one was kind of a funny one. I did also want to say you were calling out some of those content length 0 problems where there would be servers that would just ignore the content length. They didn't really care about it. There was another case that I thought was interesting that was actually in AWS that he talks about a bit earlier on. Let me just bring it up. I think it's under the section he calls the surprise factor. And this is something we've talked about a little bit before, actually. We've had some topics around this. And it's about HTTP2. So for those that aren't aware, there is like HTTP2, which is newer, obviously, and the way that requests work is very different. Instead of having like the line-based parsing with just like the keyword and then the value, they actually have fields. So in HTTP2, there isn't a content length because the length is built into like how HTTP2 works. But it gets a little bit interesting because there's a lot of servers where or like reverse proxies or whatever, that'll downgrade the HTTP2 request to 1.1 when forwarding it to the back end. So in this particular case with AWS, for example, they discovered that it was downgrading the HTTP2 request to 1.1 when forwarding it to the backend, but in the process, it was adding a chunked transfer encoding header. And because HTTP2 doesn't require a content length header, it never gets passed to 1.1. And what made this cool was the reason it went undiscovered is because browsers will always send a content length header, even in HTTP2. So this bug wouldn't get triggered by normal users. So it kind of just flew under the radar there. It wasn't really something that was noticed. But as soon as you had somebody with like a malicious browser, somebody that was playing around with the headers, the assumptions on the server getting a content length header could be broken. So this was a little bit of the opposite of what Z was talking about, where they did care about the content length header and they were expecting one to be there, but there were some cases where like you could make that not happen, and then it would just counted as 0, and that's where you had the smuggling come into play.
Well, it count it as 0, and then because it was adding transfer encoding, your body would then end up being read. You could provide it a proper transfer encoding or a proper chunked response.
Yeah.
And that's where you set the chunked response to be 0, and you can smuggle in from there.
Yeah.
No, that's the whole post. Like, there's a ton of information in this. Like, it is a really good post. Just assuming you have a basic understanding of request smuggling, there's a lot of information here about a lot of the history of the recent movements in request. I mean, a lot of that's been because of research James Kettle has been doing, so makes sense that this post has a ton of information on that, because it starts off with the classic like CLTE stuff, goes into the H2, the HTTP2 stuff, before finally about a third of the way in here, then it finally talks about the client side desyncs. Like there's a ton in this post that like I would highly recommend taking the time to actually read this one if request smuggling is at all interesting to you. Or I mean, if you're in AppSec, you should probably just give it a read regardless. But specifically on the request smuggling, there's a ton of good, valuable information in this post.
Yeah, and because of that, we can't really cover it all here. Because
I can
there's so
struggle
much,
and try to.
but yeah, I mean, there's a lot of like cool, nifty attacks there. Like the one that Z was talking about earlier too, um, with the pivot one. He actually talks about how he's admitted that to Amazon, and then he kind of regretted it after because he could have done a cooler attack. Um, what the attack he went with was, I believe he was talking about writing a desync worm. It would be like possible with using the headers to create an XSS gadget. You could basically make victims launch this same attack and propagate it that way, which would have been really funny on a test environment, a little bit less so on a production environment. So it's probably good that he reported it before thinking about that. But Yeah, just a lot of cool details in here, and like Z said, if you're into like request smuggling, there's a ton in this post. We can't really cover it all on the podcast, but yeah, it's definitely worth a read. And it's kind of it's a good resource to refer back to if you're looking for desync type issues. I think it's excellent for that. Towards the end of the post, he does talk about like some of the remediation you could have to mitigate this stuff. He states a lot of these attacks could be mitigated by simply using HTTP2 end to end instead of having this request downgrading. And like I said, like that's something we've seen before. We've covered a few topics before where it's like when you try to go from HTTP2 to HTTP1, there are so many potential issues that crop up. And it's like playing whack-a-mole with trying to deal with that downgrading. If you just had it like end to end, those issues wouldn't even really exist.
Yeah,
Some
he
of the other
also
tips, though.
he
Oh, go
also
ahead.
calls out like the one there, just don't implement your own HTTP server, and that
Yeah.
feels very much like a no duh type thing. He calls it out as equivalent to rolling your own crypto, and it
Yep.
really is. Like servers that aren't handling host, like I get it, it's kind of easy to do that sometimes, but especially for something going to production, like just use an existing library, and maybe there's still going to be some vulnerabilities there, but you don't have to stay on top of them. You just need to keep it updated.
Yeah.
Rolling your own, I mean, there's a ton of complexity to HTTP. You're probably going to get things wrong, and as we've been seeing over the last several years, like these minor differences in like how you parse something have created some very significant vulnerabilities, not just in terms of request smuggling, but also like we've seen RC due to disagreements in parsing. Server side request forgery is another one where URLs get parsed differently and writing your own URL parser. With just these sorts of minor differences in how you parse something can create very significant vulnerabilities. Um, and this is just showcasing that more, but especially with HTTP. But honestly, so many any sort of complex parser, it's probably better to use a library than try and do it yourself.
Yeah. There are some tips there for HTTP server developers as well, such as what I was talking about earlier with making sure you treat requests as separate entities, not supporting this kind of ambiguous encoding, like chunked encoding, either fully support it or flat out reject it, as well as some other tips like supporting HTTP2 and defaulting to discarding the connection if you encounter any exceptions to the server side. Now, Z, you kind of referenced it earlier in the episode, but I know there was some stuff you wanted to talk about here with the bounty stuff at the end as well. So I'll let you get into that.
Yeah, well, I was just going to shout out that you might be wondering, at a post like this where it's talking about bugs in Amazon and like Amazon load balancer. These pretty core service, like what type bounties was he. Turns out he actually opted out of even reporting through the Amazon bug bounty program because of their policy on public research. He comments here, for example, I opted out of perhaps $30,000 due to Amazon's bug bounty program being incompatible with public research. And that's kind of the case where, tying in with earlier topic about HackerOne and kind of being forced to use HackerOne, at least having the way to disclose the vulnerability if people don't want to agree to your terms, I think is important. And I just thought it was interesting to get called out here as like, um, missing out on a significant bounty simply because you want to benefit the public by providing information about the vulnerabilities. Also, kind of why public disclosure matters. It's really easy to think that any vulnerability in like some random application doesn't matter, but they can be abstracted into general attacks that do apply elsewhere, and it is important to share this information and like have a community of people learning from existing vulnerabilities. So I don't know. I mean, I've kind of dove into that before, but just a reminder about the importance of sharing your findings, even when you don't. I mean, this is something that I'm sure he wasn't thinking. Oh, this isn't an important finding, but the value of write-ups in part and being able to do that public disclosure.
Yeah, it's a strong post in favor of public disclosure for sure.
Yeah.
Um, so yeah, and it's a lot of cool research here. So it's awesome that he passed that up to be able to go public with it. All right, so our last post here is by Jubobs, and it's some research on cross-origin resource sharing or CORS. Z briefly touched on that in the last topic. This is a multi-part blog post series, but unfortunately only part one is out as of yet, so maybe we'll end up covering the other parts as they come out, but for now this is what we have. It doesn't really cover the fundamentals of CORS, though he does link to the MDN docs for those who want to get some background. But it's primarily like tips and stuff. So
Yeah,
Z, I'll let you take this one.
it's really just a few tips on, if you're dealing with core. So you've got a vulnerability, you've got like an excess, but you can't exploit it because of cores or something like that. How do you deal with that scenario? How do you look for issues or how do you look for cores misconfiguration? Sorry about that. I think I cut, but how do you look for issues in cores and like misconfigurations of cores rule? Calling out just a few things to test here. It is very much a research post. There isn't any information about a distinct vulnerability, just things that he has seen. One of the main things it calls out is, don't judge the cores configuration just from one page. These can differ depending on the page. Applications can return different headers anywhere they want. So any page can have a different cores response. So keep that in mind when you're looking for a bypass. Another thing he also calls out is that the access control allow origin, it's a response header. It's going to say like, yeah, this origin's allowed or whatever. You can only include one host in that header. But that one host doesn't necessarily reflect all of the origins that are actually allowed to make the request. So what you can do is, either spam with different host headers. There are different cases that might result in different responses there, but he just kind of calls it out as, try other hosts, try other things, or try and attack the actual whitelisting of the allowed origin. I'll come back. My thought being there, like not necessarily a brute force, but trying some like modifying your host header. One of the most common ways I've seen this implemented is the access control allow origin header will basically just reflect whatever's in the host as long as it's a whitelisted host. So as long as you're coming from an appropriate host, like, okay, your origin's allowed and it just responds with it. So you need to make a request with the right host before you can know if it's the right host or not. Just something to keep in mind when you're testing for it or testing for any issues. Also has a few ideas on where to look. One of the last things he also calls out is a common regex issue where there's example here. Where you're just having like a regex that will try and match all of the like the subdomains. So you'll write a regex that lets you hit example.com. And then all of this, and then in the optional subdomain. So if you come from like api.regex or api.example or app.example.com, whatever, the regex should match it and send that allow origin back. The problem here, really easy to overlook, is the fact that you have to escape the dot character. So in example.com, that's not escaped. Therefore, that's a wildcard. In regex, a dot or period is a wildcard character. So this will match example.com, but it'll also match wouldn't be a valid URL, but example2com. So having no dot there, of course, since this is matching the yeah, I guess this is maybe a bad example for this particular case, but or actually, does this one match? Sorry, I'm having trouble reading the regex for myself now. Either way, the idea there just being the periods being unescaped in domains in regex is a really common issue. Something, I mean, not just for the host header, I've seen this in a lot of places. Because when you look at a domain, you read it, the dot is kind of acting as it's supposed to, and you forget that it's a wildcard character and should be escaped. So yeah, I mean, he just calls out those few things that you can kind of look for, also makes a comment about cores versus same site, and he has another post that we've actually covered on the podcast regarding sites versus or same site versus same origin stuff. Ultimately, it's just a few ideas on how you might go about dealing with cores if you're in that scenario. no concrete vulnerabilities, just ideas that might inspire some of your own research. So I kind of wanted to call this one out.
All right. So that's pretty much all of the topics that we have for today. Thank you everyone for joining us. Links for our Discord and Twitter, as well as YouTube and Anchor, can be found on our site or in the chat. As always, summaries and VODs for the previous episodes will be on our website as well, which you can find linked in the description. We'll be back for our binary podcast, which will be tomorrow at the same time as usual, 7 p.m. Eastern, 4 p.m. Pacific. That'll be a bit of a packed episode, so yeah, be ready for that. And then, yeah, other than that, we'll see you tomorrow.